Hello there. Today's lesson is P.6c, adding and subtracting rational expressions, and that's all we're going to do. We are going to add and subtract rational expressions. Remember, a rational expression is just a fancy way of talking about fractions. They're just going to have variables in them, but I wanted to refresh your mind, refresh your memory, whatever. To how do you add fractions? Okay. To be able to add fractions, the first thing you need is a least common denominator, a common denominator. It doesn't have to be the smallest one, but easiest if it's the smallest one. 3 doesn't go into 4. They have no common factors. So I get that common denominator by multiplying 3 times 4, which is, which is 12. And now I know what's going to happen. Anyway, all right, so least common denominator is 12. Okay, now that means that I am going to multiply this 1/3 by 4 over 4, and I'm going to have to multiply 1/4 by 3 over 3, because remember, whatever you do to the bottom, you also have to do to the top. So I write them over the same denominator, and I'm going to get 4 plus 3 over 12. 4 times 1 is 4, 1 times 3 is 3. Same denominator, they both have a denominator of 12. So I don't write 4/12 plus 3/12. I'm simplifying the process and just writing 4 plus 3 all over 12. And then, of course, you get your answer of 7/12. So that is the process of what we're going to be doing. We're just going to have rational expressions in it. Okay? So here we go. Okay, look at our first example, subtracting rational expressions with the same denominator. So we got x over x plus 1 minus 3x plus 2 over x minus 1. We have to remember still that x cannot be -1 because -1 makes that denominator 0. Okay, but as we just did with numbers, I have the same denominator, so I'm going to combine the top. I don't know why that happened. Okay, so I got x plus 1 on the bottom, and on the top I'm going to have x minus, and what is the top of the second one is 3x plus 2. And so I really want to put out these parentheses, y'all, are very important, because I'm telling you, somebody's going to make a mistake of not distributing that negative to all of the numerator. But that's where you're going to mess up if you mess up. So anytime you have subtraction in these problems, you're going to see me put a parenthesis in there. Okay, so on the next step, you can go ahead and combine. X minus 3x is -2x, and minus a 2, positive 2, is, of course, minus 2. Again, y'all, the denominator is staying the same each time. So when I carry that down, okay, to the next step, you need to notice that there's a common factor of -2 in that numerator right here. So I'm going to factor out a -2. And when I do, I have x plus 1. And of course, that is the same thing on the top and the bottom, which leaves my final answer to be -2. And of course, x cannot be -1. And that's it. Okay. Now, that was with the same denominator. If we have a different denominator, we're going to talk about how to do this with rational expressions. So first off, you're going to factor each denominator completely, list the factors of the first, add to the list anything you don't have in the first when you factor the second one, and then form a product. And that will be your least common denominator. So look at this problem. 2 over 5x plus 20 minus 3 over 2x plus 8. So the first thing I'm supposed to do, I need to factor both of the denominators. So that's 5, common factor of 5, common factor of 2. Okay, all they're asking me for is to find the LCD. So I'm just showing you factor both of them. So my LCD is going to be, I write what I see in the first one, and then what is different. Okay, only what's different, y'all. X plus 4 is already here, so I don't write this one again, but there's no 2 over here. So technically I'm writing a 2 down here, but in my answer, I of course need to simplify that and multiply the 2 times the 5 to get 10 times x plus 4. Okay, so now let's talk about adding and subtracting rational expressions that have different denominators. So first we have to find that least common denominator. then rewrite them with the common denominator, add or subtract our numerators, and then if possible, we're going to simplify the rational expression. So you got to always think about factoring when you're doing these kind of problems. Okay, so here is our problem. The first thing that we are supposed to do is to find a least common denominator. So my least common denominator is, I got to factor the first one. That's a PST. I have to factor the second one. It has a GCF of 2. Okay. And while you're here, you might go ahead and say, okay, remember what makes that denominator 0 is x equal to 5. Okay. So my least common denominator is, I have writing the first one, which is x minus 5 squared. And then what's different, I already have an x minus 5, so I don't write this part again. I'm only going to put the 2 in front. So that's my least common denominator. Now, the second step is to make the denominators the same. So when you've got this factored, and this is my LCD, hopefully you can see what we're missing is a 2. So to get that common denominator, I'm going to multiply the top and bottom by 2. And on this one, on the second one, I'm going to multiply the top and bottom by x minus 5, because there's 2 x minus 5s over here, and I only have 1, so I need another one. All right, so on step number 3, I'm going to multiply out those numerators so that I can simplify my expression. There it is. Okay, so to do that, I've got my bottom, which is 2 times x minus 5, quantity squared. And then on the top, the first one, 2 times x is just 2x. And then I minus, remember I told you whenever I see a minus, I'm going to put parentheses there. And x minus 4 up here, x minus 4 times x minus 5 is, if you FOIL, of course, x squared minus 9x plus 20. Okay, so when I simplify that, on the bottom it stays the same. I have a negative x squared. We generally write these in what we call standard form, so the highest exponent first. So you got to think about the fact that the sign of each of these terms has been changed to the opposite because of that minus sign. So I'm going to have minus x squared. 2x minus a negative 9x is 2x plus 9x, or 11x. And then I have minus 20. And x, again, cannot be 5. So that's all we got there. All right, number 4. These are completely different. So the one I just did, y'all, factored, they had a common factor. Let's hope these have a common factor as well. All right, so when I look at them, I've got, first thing I'm supposed to do is find that LCD. Okay, so I've got to factor the first one and factor the second one. All right, and so I'm going to write down everything that I see in the first one, and then what do I have in the second denominator that's not in the first, and that's an x plus 2. So my second step is to get the numerators, or to get the denominators the same, and I have to multiply the top and the bottom by the same thing. So this guy has x plus 6, x minus 1 has that. I need the x plus 2. So I have to multiply the top and the bottom by x plus 2. The second one has x plus 2 and x minus 1. So I hope you can see that it needs x plus 6 over x plus 6. So my third step is to write those together so that I can simplify my numerator. So on the bottom, it doesn't change, x plus 6, x minus 1, x plus 2. 4x times x plus 2 is 4x squared plus 8x. I have a minus again. If I have a minus, y'all, I'm putting parentheses. 3x times x plus 6 is 3x squared plus 18x. So when I combine that, my bottom, again, is not going to change. 4x squared minus 3x squared is x squared. And then I'm going to have 8x minus a negative 8x is negative 10x. Okay? If you look at x squared minus 10x, it does factor. It factors to x times x minus 10. But I don't have either of those factors here, so I can just leave it like that. But I got to remember that x cannot be, oh, I didn't do it up here, did I? Funny. x cannot be negative 6, 1, or negative 2. So I'm going to have the same thing down here. Even if anything canceled out, okay, some of y'all have had trouble with this, but even if something comes out, you got to go back to the original problem, the original denominator, which is all of this right here, to figure out what x cannot be. Okay, last example. I have x, again, different denominators. 2x squared minus 12x minus 15 over that long mess, minus x over x plus 1 plus 14 over x plus 2. So I have 3 different expressions here. We're still doing it the same way, y'all. Okay, so I'm going to start off with first finding that least common denominator, which means I have to factor this guy, x plus 2, x plus 1. And if you notice, that is what these two are. And most of the time, y'all, when you do these problems, that's what's going to happen, because they're contrived to help your factoring and to help solidify the concept. We're not trying to make your life difficult. So if anything, multiply these two out and make sure that's what you get. And you will see that that's what our least common denominator is. Okay, so I already have that here. I don't have to multiply by anything. I do not have it in the second one, so I'm going to have to multiply everything in that second one. I didn't want to do that. I didn't want to do both of them at the same time. Sorry. Multiply it by x plus 2 over x plus 2, and multiply the second one by x plus 1 over x plus 1. So what is that going to look like? All right, so I've got x plus 2 over x plus 1 on the bottom. That first expression, this guy right here, y'all, he didn't change. My denominator didn't change, so I'm just going to go ahead and write him. Okay, I have a minus, which means, you know me, I'm going to put parentheses. X times x plus 2 is x squared plus 2x. And 14, this one is just plus, so I don't have to have parentheses. But I have 14x plus 14. All right, so now I'm going to simplify the bottom. Excuse me, I didn't mean that. Simplify the top. So 2x squared minus x squared gives me x squared. Then I have minus 12x, a minus 2x. That's minus 14x. So I can see these two make minus 14x, and that's plus 14x. So those are going to go away. And then minus 15 plus 14 is going to be minus 1. So this is one where you've got to recognize, that's why I keep telling you on that one we did earlier, you got to recognize the difference of two squares is a D2S, so it's going to factor 2, x minus 1, x plus 1, which means I'm going to have the common factor on the top and the bottom of x plus 1. And that will go away, leaving me with x minus 1 over x plus 2. Again, you have to go back up to the very beginning, which I seem to keep forgetting. X cannot be negative 1 or negative 2. Even though it only looks like negative 2 down here in the answer, y'all, you still have to list both of them. So be aware of that. Okay? That is all that it is. I hope you remember what is most important about being able to add and subtract rational expressions. Thank you so much for watching, and y'all have a great day.